So hello everyone. Today we will study rectifiers, one of the fundamental circuits in electronics. Rectifiers can convert alternating current into direct current. They are widely used in power supplies, chargers, and almost all electronic equipment. We will look into types of rectifiers, their working, waveforms, advantages, and applications. Introduction to rectifiers. Introduction to rectifiers. A rectifier is an electronic circuit that converts AC into DC, AC current into direct, alternating current into direct current. The key component of a rectifier is diode, so which allows current flow only in one direction. AC constantly changes its direction, whereas DC flows steadily in one direction. Since most of our devices require DC rectifiers play a vital role in converting household AC to usable DC for circuits. Types of rectifiers. Rectifiers are mainly classified into half-wave and full-wave rectifiers, and in these full-wave rectifiers, we have center taper transformer type and bridge rectifier. So rectifiers are mainly classified into half-wave and full-wave. In half-wave rectification, only one half of the AC cycle is used, but in full wave rectifiers, both halves of the AC cycle is used, giving a higher average DC output. Full wave rectifiers can be constructed using center taper transformer or using four diodes in a bridge configuration. Apart from these, advanced rectifiers use SCRs for controlled rectification. Half wave rectifier. In a half-wave rectifier, only one diode is connected to the AC source. It conducts only during the positive half cycle of the AC input, and it blocks the negative half. As a result, the output is pulsating DC but contains large ripples. This makes it inefficient for most applications. However, it is simple and often used in basic signal demodulation. This slide shows the circuit diagram of a half-wave rectifier where It acts, the diode is forward biased. It acts as a short circuit. When it is reverse biased, it acts as an open circuit. So this is because of the connection architecture of the circuit. The anode terminal of the diode is connected to the secondary of the transformer, and the cathode terminal of the diode is connected to the load resistor. So load resistor. Thus, the diode conducts during the positive half cycle of the AC input, while it will not conduct during the negative half cycle of the AC cycle. So the voltage drop across the load resistor will appear only for the positive half of AC. During the negative half of AC, we will get zero DC voltage. So full wave rectifier. Full wave consists of two diodes and a transformer, step down transformer. So this transformer is center taper transformer. When we apply AC voltage with 230 volts, the step down transformer reduces its amplitude to 9 volts or something less than 230 volts. So the anode terminal of the diode is connected to the secondary winding of the transformer, and the cathode terminals of the diodes are connected to the center of the center taper transformer. And these cathode terminals are also connected to the load resistor. Load terminal. So when positive half of AC cycle passes through transformer primary winding, then due to mutual induction, the top of the secondary winding becomes the positive, while the bottom of the secondary winding becomes negative. So for the positive half cycle, only D1 conducts and D2 doesn't conduct. So for positive half cycle, only D1 conducts, but D2 doesn't conduct. So when the negative half cycle of AC passes through primary winding of transformer, then due to mutual induction, the top of the secondary winding becomes positive, negative, and the bottom of the secondary winding becomes negative, positive. So due to this, the diode D2 conducts and D1 doesn't conduct. So as a result, both the positive and negative half cycles, uh, both the positive and negative half cycles are conducted. The output is like this, the pulsating full wave DC output. And this is more efficient than half wave rectifier. It has higher DC level and less ripple. So now we will be looking into full wave rectifier bridge type. So the bridge rectifier is one of the most common rectifier circuits. It uses four diodes arranged in bridge configuration. So during the positive half cycle, two diodes conduct. So we know the function of the transformer, what will do. And when during the positive half cycle, the diode D1 and D2 will conduct. And the output of this is available at the load resistor. And during the negative half cycle, two resistors will conduct, and those two resistors are and D4 and D3. And the output of this half cycle is available at the load resistor across the load resistor. So the output is pulsating DC for both halves. This eliminates the need for a center tapper transformer and makes the design cheaper and more efficient. So we have seen the center tapper transformer. The center tapper transformer is a bit costlier than the regular transformer. So using bridge rectifier reduces the cost of center tapper, reduces some cost. So the table compares half wave, full wave rectifiers. So we can clearly see that half wave rectification is least efficient, while full wave methods give better DC output with less ripple. So the ripple factor of DC is 0.482, whereas the ripple factor of half wave rectifier is 1.21. So the full wave rectifiers provide less ripple, and the efficiency of the full wave rectifiers is much larger than the efficiency of the half wave rectifiers. So the voltage regulation is good for half wave rectifiers, but it's better than half wave rectifiers for full wave rectifiers. So these are the other characteristics of these two kind of rectifiers. Applications of rectifiers. So rectifiers have countless applications. The most important use is in power supplies. So they provide DC for electronic gadgets like mobile chargers, TVs, and computers. They are also used in battery charging, AM detection, AM radio detection, welding machines, and motor welding machines and motor drive circuits. Without rectifiers, modern electronics wouldn't function. To conclude, a rectifier is a crucial component in various electronic circuits. This is because most of the electronic circuits operate on low voltage DC, and it is economical to supply power in the form of AC. So we need a device which can convert AC to DC. A rectifier is a device that converts AC voltage into pulsating DC voltage. The pulsating DC voltage consists of AC ripples with DC voltage. So it is called pulsating DC voltage. The half wave rectifier converts full half cycle of AC into pulsating DC, while the full wave converts full cycle into pulsating DC. Our selection for half wave and full wave rectifier should be based upon the requirements. If we require a low cost device and if you can compromise with efficiency, then use half wave. But if you are working on some specific circuit designing which requires highly efficient conversion to of AC to DC, then use full wave, keeping in mind its circuit complexity and high cost.